Okay, so the mid-segment of a trapezoid is a line, basically, a segment that connects the midpoints of the legs. So the midpoint of each leg is exactly halfway between the length. Okay, and then the mid-segment connects those two halves. Now, if this is isosceles, all four of these will be the same length. But since we haven't said this is isosceles, these two are the same length as each other, and these two are the same length as each other. But we don't know about a relationship between the two legs. But the mid-segment will connect the halfway point to the halfway point. Okay? Then we have a mid-segment theory. So the mid-segment of a trapezoid is parallel to each base, and its measure is 1/2 the sum of the lengths of the bases. So I'm going to write that up for just a second. Hold on. Okay, so the way this works is we have a trapezoid with a mid-segment. AD is parallel to BC already because that's the definition of trapezoid. You have two parallel bases. But then they're also parallel to PQ. So they're all three parallel to each other. And then PQ is equal to 1/2 of the length of AD and BC. If you don't like fractions, you can do it this way. And then divide it by 2. Okay, so either of these formulas, it's the same thing. It's just how do you prefer to look at it? I don't care which because it's exactly the same. But you need to know that this length is half of the sum of those two. That's the mid-segment theorem. Let's find x. We have the mid-segment. We have one base. We need the other base. So our formula tells me that LH is going to be equal to FG plus KJ divided by 2. If you don't like using the letters, you could say mid-segment is equal to base 1 plus base 2 divided by 2. Okay. Either way, I know that this is 15. That's x. That's 18.2. And now I just have to solve for x. So to solve for x, I'm going to multiply both sides by 2 to cancel those 2's out. And I get 30 is equal to x plus 18.2. And then I subtract 18.2 to get x by itself. 30 minus 18 is 12, minus 0.2 is 11.8. So x would be 11.8. Okay, so another example. Same shape, different numbers. So LH is the mid-segment, so 13 will be equal to the two bases divided by 2. So multiply by 2.
Wait, so you add the two bases together?
Yeah. Yeah, it's the two bases added together, then divided by 2 gives you the middle. So multiplying by 2, I get 26 is equal to y plus 25. And then if I subtract 25 from both sides, y would be equal to 1. So this would be really skinny at the top trapezoid, but it still works. All right, I've got this picture. It's a sideways trapezoid. I've got A, F, and B. I've got D, G, and C. I've been told that FG is parallel to AD. Well, it's a trapezoid, so I know that AD is already parallel to BC. If FG is parallel, it's going to have to be a midpoint. That's why it's not so pretty. Okay, if FG is a mid-segment, then G is the what of this line? Midpoint. So we can find this using the midpoint theorem. Or formula, sorry, not theorem. Okay, so that's the midpoint formula. Do I have to do the whole thing? No, because it just says find the x, right? So I just have to find the x. So I'm going to add 1 plus 20 and then divide it by 2, because those are the two x's, which gives me 21 halves. Yep. The kite that you fly, the original shape, was named after the actual shape of kite. So that's where the shape comes from. You have two pairs of consecutive congruent sides, so the two together are the same length, like that. So, so a kite is easy to remember the name of because it looks like, you know, the kite that you fly. So if, oh, I don't know what happened to my E. Got cut off. Okay. If you have a kite, then the diagonals are perpendicular. So if you put diagonals, they're perpendicular. Okay. So right, if you have a kite, oh, that my typing was apparently way off. Okay. You have one pair of opposite angles are congruent. Okay. Are congruent. No, pair is. That was correct. One pair is congruent. Okay. These ones. Okay, so the congruent angles.
I think it is R.
No, pair is. It's the pair that is congruent. Oh, well, whatever. Okay, the congruent angles are located where the non-congruent sides meet. Okay, so these are the congruent angles, not these. We know that this is a quadrilateral, so the angle sum is 360. Because it's a kite, these angles will be the same. So we can use the sum, the angles that they've given us, and the fact that these are the same to find out which each of them is. So first we say 360 minus 128 and 72. Okay. That's 200. Do you guys agree with my adding?
Yeah.
So it leaves me 160 degrees. Well, these two together make 160 degrees. So they're 80 degrees each. Did I lose you? Okay, so the whole thing's 360.
All the time?
If it's got 4 sides. If it has 4 sides, it's 360.
I thought 360.
Okay, so we knew what those two were, and we know that these two are the same because it's kite. So I subtract these two from 360, that leaves 160. And then I divide it by 2 because those will be the same. Better now? Okay. We have a kite. That tells me that this is 90 degrees. I want to find this side. What kind of triangle is this? A right triangle, right? And in a right triangle, you guys remember the Pythagorean theorem?
A squared plus B squared plus C squared.
So this would be A, this could be B, and this would be C. So 8 squared plus 24 squared will give me C squared. So 64 plus, who has 24 squared memorized?
It's right here. 4.26.
Okay, 576 plus 64 is 640. To find out what C equals, I take the square root of both sides. It's not perfect, so I'm going to simplify it. I made a factor tree of 640, except my factor tree went crooked because I ran out of room. I have 1, 2, 3 pairs of matching. That's a terrible circle.
Could you just take the square root of 640? Do you have to do that?
Yeah, because you guys need to practice doing this.
Oh. Put it on the calculator.
So we have 1, 2, 3 pairs of 2. So those are 3 perfect squares inside, right? Every pair is a perfect square. So there's 3 of them. So it's 2 times 2 times 2. So that's 8. And then 5 and 2 are left over. And leftovers get left inside. Okay, so let's just practice a couple more of these. If I want to do the square root of 450, what can I divide it by?
45 and 10.
And 45 is, and 9 is, okay, so look at this. I have a pair of 5s, and I have a pair of 3s. So the 2 gets left behind. 3 times 5 is 15, and the 2 got left behind. We can do 30 and 10. Okay, now we have a pair of 2s, and I have a pair of 5s. Even though they're not connected to each other, it is a matching pair of 5s, right?
Explain.
As long as you have 2 of the same number, it's a pair. So they don't have to be right next to each other. There's a 3 that's left. So this is going to be 2 times 5 with a 3.
How did we get 15? On the other one, I was looking at that, the 15 on the outside, I think 15, we added them.
15 times 2 is 30. Oh, this 15?
Yeah, that 15.
3 times 5. 3 times 5. Okay. So if you need more help with these, just let me know and